Hello, is it just me or I also can't hear Shinjin?
No, I can't either.
Just, so if you can hear Shinjin, you can just maybe notify in the chat box. Sure, okay. Shinjin again. So this is what I've been busy with in the meantime. I'm trying to create a node generator to link on the front end side where you can actually click the number of nodes to generate, and I think it makes sense now. Well, I think it's working. I just need to verify again. But the idea is in this function generator, you can specify the coordinates. What's the word now? You can specify the maximum and minimum coordinates. So here I'm saying I want you to create a node between, I want you to create 5 nodes within the coordinates of x0 and xy0 and xy26. So that's what you see in the first 5 things here. So you can see xy. What's z1? Yeah, z1 is just what's the word now? The initial boundary and the maximum. What's the basically the minimum and the maximum value. And then the n is how many times it should be created.
Sorry, can you guys hear?
Hi, Shinyan, yeah.
Hello.
Yes,
Good
good
morning.
morning. Oh, good afternoon.
Yeah, I think, yeah, good morning. Sorry about that. All right, so Victor is already doing the thing.
I'm just taking a little through what I'm planning to sort of what I'm currently doing. Yeah.
Quick question: is Herman coming up today?
I'm not sure.
From the Slack messages, it doesn't seem he is joining us today.
Oh, okay, okay. All right, so let's just continue.
Oh,
All right.
okay. Just getting.
Okay. All right. So, okay, interview. All right. So
okay.
Please go ahead. Yeah. So Victor, go ahead and we can do this thing. Yeah.
So everyone. So I did discuss with a little yesterday, and one of the things we sort of talked about was doing the data processing with MATLAB. The action on me on that is just to write down the specifics of the kinds of data that needs to be processed. So for example, if we are saying we're checking the latency, what data we pull in from the origin match client or matcher, and what are we pulling from the destination, and basically what are we plotting against what or where. And that's what needs to be written down on paper properly. In the meantime, I'm trying to create a node generator, or a proper node generator that can be linked to the front end stuff that what's his name, Debo built, such that you can actually specify the coordinates. Say I want to create a node in the quadrant A where between 0 and 25, for example, here. I'm saying I want you to create, maybe I should make that 1. But the idea is create random values of x between 1 and 26 with 5 times, basically five, yeah. And then when you create that, you generate that. When you create for another quadrant, and the idea is here we can say something like, we want to create this either to a file or on the go. When you create this, it creates this amount of nodes, 5 nodes. It also creates 5 nodes here, and then we can sort of click a button on the front end to suggest, okay, after you create this node, deploy the nodes and start publishing or subscribing. So basically, the test it pops up implementation. Let's see. I think there was one other thing here. Sorry. In terms of Where are you? Sorry. It's a big one. Yes, global control. Okay, yeah, I think that's more or less it. I don't know if you want to update the team manager on your progress.
Okay, yeah. So I basically had a meeting with both Victory and Prof. Herman yesterday about the how we will be almost, I want to say, comparing the data of the, because I'm doing the simulation or we're working on the simulation at the moment, and basically just spoke about how I can create the logging files and then use Python to check the validity of the simulation basically, and then eventually it will be possible to apply the same tests to a real world scenario, in our case probably on the Raspberry Pis. So I'm just currently working on changing most of the login files so that I can get the data that I want to manipulate in Python, and then hopefully I'll be able to get a successful comparison of the simulation so that I can start simulating the nodes moving and actually showing the data of the nodes moving working.
Okay, nice. So when you talk about process by Python, what does that mean? Does that mean that it's read from a text or a log file?
Yeah, so yeah. So from the idea, the log files at the moment are JSON files, I'm pretty sure, and that I'll just be able to pull into Python and quite easily, in theory, manipulate.
Okay, I see. Okay. So, but the simulator itself, it's in JavaScript.
Yes. I'm just reading the. I'm just reading the information of the completed simulations into Python, and then yeah, you basically just using Python as a data analyzing tool.
Okay, nice. So I guess another question is, so the simulator, does it basically move nodes in time step?
Yes, well, that is the theory. It hasn't yet, it's not yet doing that, but hopefully I will be able to.
Okay, I see. Okay. So probably you will be generating some movements, right? Kind of like
yes,
some kind of behavior, right, for each node.
Yes.
In a sense. Okay. All right. So all right. I guess just a quick feedback that there has been some existing behavior model files that you potentially can utilize or have a look at. Okay, I mean that was used in previous simulations.
Okay.
Yeah, I think probably something on the name of a behavior model. Okay, you can dig into the previous codes. Or I mean, I'm not sure if it's in the JavaScript, but in the C++ version, there were definitely some codes that were like that. And there's what's called random movement and also cluster movement. Okay, just so that you know. And the idea of cluster is it's more like human behavior because people tend to move in clusters. And what it does is it has different attractors that's randomly placed. And basically the attractors would pull the nodes towards it. And then the attractors also move. I think that was kind of the idea. Okay.
Oh, I understand. Yeah.
Yeah. So you can actually, if you look at the vast SourceForge site and the video, if you've seen that, that's the cluster movement. Okay. That's
okay.
Yeah. You probably have seen that, right?
Yes.
That's that is the cluster movement model. So, and that's probably a more accurate model than fully randomized movement. Okay.
Okay.
Yeah.
I'll look into that then.
Yeah. Okay. All right. Just a feedback. All right. So yeah, please continue.
No, that's
yeah. Okay. All right. So Victory.
Thanks, Shinyan. There's nothing much from Didier, for example. I think he's writing today, but he did say we can meet, I think, later after his exam today to discuss next steps. But yeah,
Right, so he's
me-
responsible for build the global controller now, right?
yes, but
Okay.
the idea is to sort of give him the direction as to which path to take, especially when we're talking about, I think for me, the most important part is this batch run function, where when you click a button, it runs a set of data, a specific set. And the reason why is once you have that set of data, or not data, sorry, like client configuration, once you push that button, you're basically, you can run the same experiment multiple times to evaluate the performance.
Okay. Okay.
Such that
So
it's not always random values.
I see. So just some clarifying questions. Is the movement going to be pre-generated before the, I guess, before the actual test experiment is taking place? Or is that generated on the fly?
So at the moment, the movement has not been integrated yet, or this the plan is to sort of integrate the movements with Alida's work once the front end side of Debo's stuff is working properly, then to sort of integrate that into the global visualizer. And then we can see what the movement is doing while at the same time integrating this batch import function. I don't know if that makes sense. So it's like, once we have that running, then we can ask Alida, okay, what does your movements look like? I am guessing there's a way Alida is calling the IDs of the nodes. I'm not sure now. But then again, closer to the time we'll be discussing. I'm guessing she's calling the IDs of the nodes. So it means we might have to find a way to integrate that or implement that in our code, and then basically merge both front end controllers and then see what comes out of that in terms of the movement.
Okay, nice. And another question is, logs are expected to be taken, right? I mean, as you are moving and collecting, right?
Yes.
And is that going
Yes.
to follow the same format as what Alida will be producing from the simulation?
Yes. So I'm not sure if Alida has gotten to that point of logging the data yet, but the format will be more or less the same. Again, we do sort of plan to sort of collaborate as the time sort of goes closer. Or for example, when she gets to the login side of things, I'm just going to show her the function we created in the library, and then she can maybe use that because the function has the same, basically the standard format.
Okay.
And then
okay. All right.
yeah,
Yes. Yeah. All right. So I guess it's just I mean it's actually really just one feedback, is that you guys can actually share, I think, in terms of the behavior model, the intended node movements, whether it's for experiment or for simulation, and also the post, the data analysis part. Okay, because really we all want to figure out the same thing, whether it's the correctness, right, the consistency, and all that. So basically, I think that's kind of the beginning and end of the simulation or experiment. I think those parts actually, you guys can utilize the same resource and the same code base. So
yes,
I mean, if that's but if that's the case, you might need to discuss first, like maybe who's going to develop what first, and how is that going to be shared?
Okay, makes sense.
We started to touch onto that yesterday, and I asked Victory to basically compile, and I'm also busy compiling a file for what we want the login to be. I'm not currently working on the login for the movable nodes, but I'm moving on to that as soon as it works for the stationary nodes. And then we will be able to compare what data we are using, and from that it should be exactly the same.
Okay,
so in
nice.
theory we would be able to help each other.
Yes, that'd be nice,
Yeah.
because then it will also be very nice to have comparable results, right? Meaning that if you use the same
Exactly,
methodology
yes.
you can actually see like, is there like a difference between
Yes, because
running
I was
simulation and
speaking to
experiment?
Prof. Herman
Yeah.
about that yesterday as well, and he mentioned that there will probably be a very big difference because in the simulation everything is synced to the
That's
time,
right.
and then obviously so
Yeah,
that is
that's
the
the
idea.
perfect world, that is.
Yes, exactly.
If
So
everything, yeah.
the idea is to create the login tests in collaboration with Victory.
Okay, nice.
Yeah.
All right. Okay. So Victor, please
Exciting
continue.
times. Yeah, so yeah, the exciting stuff is going on at the moment, I think, in terms of development work. But in general, I think it's going well, or at least it's progressing well. There's still one or two, for example, when we actually start to log in and processing the data, there's still a bit of fuzziness as to what data to collect, and maybe, well, not what data now, in terms of, for example, when you process the latency, what should be on the x-axis, what should be on the y-axis, what are we measuring again, stuff like that is a little bit fuzzy.
Okay.
But I
all
think
right.
that sort of gets clearer once you have like your data set, and then you can visualize when you start plotting graphs and
Okay.
start
All right.
plotting.
All right. Okay. I see.
Yes, I've
Go ahead.
sorry. No,
Go ahead.
I've started doing quite a lot of that, so I'll probably just randomly call you throughout the day, and
No worries.
ask what. Yes, so we should probably speak about that,
Okay.
just to ensure that we have the same data that we want.
Perfect.
Okay. All right.
Thanks a lot.
So, sorry, Victor, you were saying?
No. Thank. I was just saying thanks to Alida. Yeah,
Okay.
we should definitely do that. Yeah.
Okay. I guess this is something I can maybe spend a little time talk about. Okay, just to clarify this aspect. I mean, I'm going to share, maybe this is more from a high level perspective. Okay, but obviously, if you know the ideas, you can find ways to implement. It's really that what you want to capture is the specific locations, okay, of each node and the neighbors that they're seeing at each timestamp. Okay, this will be easy for Alida to capture because she's running basically ticks, within the simulator. So like, I mean, the output she's going to get is something like, okay, at this timestamp, like this is the current state of all the nodes in terms of their positions and the neighbors they're seeing. Okay. And the neighbors, meaning that I guess the publish, I mean, the subscribe results. Actually, nodes will be publishing potentially their positions, right?
Yes.
So basically, you will get like a you will subscribe to that and get to see who are your neighbors and what are their announced positions. That is okay. That kind of things. And I think for the real experiment, what you need to do is you also need to log in terms of that kind of raw data, in terms of the positions of other nodes, and also the neighbors they are seeing through publish and subscriptions, okay? And the respective the locations of the neighbors. All right. But here, something additionally you need to work on is you have to make sure that the timestamps are sort of sync at the beginning. Okay. So that, let's say you're taking one snapshot, like maybe every second, for example. I mean, I'm just giving an example. It can be more, like maybe 5 snapshots every second or 10, right? but let's say it's once every second. That is your timestamp. So before that, it's actually important that you have some way to sync the clock at each of the nodes. You see?
Okay.
Okay. So this is something, you know, I suggest you, because they potentially can be at different physical hosts, right? And the clocks, if not sync, then definitely, you know, the results will be off, right? You see? So probably the timestamp, I mean, at least the clocks should be somehow synced before you start. And then maybe, you know, taking snapshots, let's say every second. And that's going to be like the raw materials, okay, for analysis. And then you can analyze correctness, okay, in terms of you know, if we use the matrix consistency, that's you know, topology consistency. That is, let's say you're supposed to see 10 neighbors, okay, but if you only see 9 of them, that's a 90% consistency for you. You see? Okay, so that is the part the Python code, you know, Alida is doing, potentially can analyze. Does that make sense?
So just to check, so when we say we want to check the you know, the location of nodes and their neighbors, are we saying we want to check their neighbors in terms of ID?
Well, okay.
Position?
Yes, there are two things. Neighbors in terms of IDs, that is for topology consistency. Okay.
Okay.
Like, let's say I need to see neighbor 3, 4, 7, right? But if I only see neighbor 4 and 7, right? Then one neighbor is missing, right? That's a 66% consistency. You see?
Okay.
Does that make sense?
Okay.
Okay.
I see what you mean.
So for that, you can simply check against node IDs. That's fine. All right.
Okay.
However, you can imagine, even if you know all the 3 neighbors correctly, but let's say their positions is off by, you know, like 2 kilometers. Sorry, 2 meters. That's right. Then you wouldn't also say it's very consistent. For that, previously we have defined what's called drift distance. Okay. So the drift distance, that's defined as, you know, at that snapshot, at that timestamp, what's the difference between the observed position and the actual position of the node? You see? Okay. And it's actually necessarily going to be somewhat different. In the physical world, it's going to be caused by latency, right? Because there's latency, you see? So you necessarily will have some kind of drift distance, and that's only to be expected. Okay? In the perfect, you know, simulation world, it's potentially also possible to have drift distance. If you, let's say, if you add some delay to the, you know, the position transmission. For example, if you are publishing my position at this timestamp, but that's received at the next timestamp, for example. Okay, if you consistently do that, then, you know, when it's at the next timestamp, when you check the observed versus the actual position, it's going to be off by a little bit. You see? Does that make sense?
Yeah.
So even if simulators, if you really do a fine scale simulation, you may also observe drift distance. Okay, somewhat. But let's say you just check, like, you know, if you're not that refined, it's potentially you can get like a very perfect, meaning a very small, low drift distance. Okay, is what I'm saying so far making sense to both of you, Victoria and Alida?
Yes, I am. I'm following the train of thought. Yes.
Okay. Alida, is that also all right? Because I mean, your Python code
No,
potentially.
it makes sense. Yes,
Okay, you get the idea, right?
Yes, it's very in line with what Prof. Herman was speaking to me about yesterday.
Right. Okay. So this is potentially the part about the correctness, okay, of aspect of the of our spatial PubSub. There's another aspect which is the performance aspect. Okay. So the performance aspects mostly relates to one will be bandwidth usage. Okay. And that is something, either from a simulator or experiment perspective, it's something you can measure and capture. Okay. And that is simply recording, the inbound and outbound bytes or bandwidth use, at each node. So you can use that as a metric to see, for example, as the number of nodes increase, right? Let's say the system starts from 100 and then it goes to 200, 300 to up to 1,000. You can actually see the bandwidth usage per node and see if they actually increase, linearly or maybe sublinearly. Okay, and that potentially determines whether the system is going to scale. Okay. Is it making sense so far? That's the bandwidth aspect.
Yeah.
I mean, it should be relatively easy to capture the bandwidth. That's what I'm trying to say. Okay, bandwidth should be.
No, that's.
Yeah.
I did actually ask. I hope I don't forget my question now. So, so when we capture that, for example, in a practical, let's say our simulation case, and want to sort of show the number of nodes increasing, are we doing this manually or?
Oh, okay. Well, you can preferably. Well, in the past, when I did that, I think I had set up different config files, right? Let's say running 3,000 timestamps with 100 nodes, and then the next one would be like for 200 nodes, for example, right?
Yes.
And then but you want to automate this for sure, right?
Okay.
If it's parameterized, then you can just simply run a whole batch of them, like let's say 100, 200, all the way to the 1,000 or more, and then collect and analyze at the end. Okay, although each individual one could be they could be individually run. Okay.
Makes sense.
But I guess don't overcomplicate and don't try to over optimize at this point. If you just run one and you by hand one set after another, that's also fine. Okay. Okay, so the more tricky part I'd like to say is the latency part. Latency in the simulation case would almost, it's kind of like you define that, okay? Because you're running timestamp. But I think for the actual experiment, you might need to find some ways to figure out the latency part. Okay. And and I mean, because in the end, actually, it's not just about the latency between nodes, but actually between a published message versus when it is received. You see?
Yeah.
Yeah, because that's actually the more relevant measure the application will care. Okay, all right. So is it so far regarding? I mean, does this help to clarify maybe what's needed to be?
Yeah, it does. It helps. Yeah.
Okay, all right. So yeah, so I think Victor, you can plan ahead for today now. And any questions from our leader?
Not currently, no.
All right. So yeah, I think yeah, we get to this stage first. Latency might be something have to think about how to collect that in a meaningful way.
Okay. Control. So Alina, we can sort of align as the day goes by, right? Because
Yes, 100%.
yeah,
I'll be working on the simplistic version of the login file, and then I will speak to you as soon as I get that working about what data you would prefer.
thanks, Alina.
Okay, all right,
Yeah, I
good.
think
So any other
changes.
all right.
So for me, I'm also discussing. So I just need to write this. Let me write that down. Right, a to-do list. Okay. Sounds good.
Okay, all right, good. So any other questions or feedbacks? Okay, so
not from me.
okay, so if not, then well, yeah, see you tomorrow then. All right. So thanks for
See you
today.
tomorrow.
Yeah, all right. So see you. Yeah.
Thanks everyone.
Yeah, thanks.
Thanks,
Yeah,
Shinji.
bye-bye. Take care. Yeah,
Thanks.
bye-bye.
Bye.
Thanks, Alida. Bye.